Good morning all. Here we are, another day at the shop. We have a KEB HOMAG F4. It's article number 16.F4.C1H-4A01/2.2. The complaint with this drive is that it would not power up. Before I throw the smoke at it, I got to make sure that line to plus bus and bus ground are not shorted, and UVW output to the motor to bus plus and bus ground is not shorted. I always do that. It's one of the first things I do after I pull the cover on a drive, because you'd be surprised where when we power these things up and we have a short circuit, we make more problems than we had before we did that. So let's go and check our power devices. Okay, I'm going to take my black lead and put it on bus plus. There's a terminal right here. It's frame ground, bus plus, bus ground, and PB. That's your regenerative braking output. Over here, we can't see it, but it's L1, L2, L3, and again frame ground, PE. Over here on this side, we have frame ground, PE, U, V, and W. So I take my black lead and I put it on the plus sign, bus plus. What do we have there? We have 0.466 volt diode drop, not shorted. That's L1 with the red lead. Here's L2, 0.468 volt diode drop. Here's L3, black lead on bus plus, red lead on L3, 0.469. The line side, the bus plus, is not shorted. Let's go and put our red lead on bus ground, 0.508. And here's our red lead on PB, 0.376. Red lead on U, black lead on plus, 0.371. Here's V with the red lead, 0.371. Here's W with the red lead, 0.371. I hope I'm not getting my head in the way. I'm trying to bend around and look at that meter. Okay, so bus plus, L1, L2, L3, UVW is good, and PB. Now we're going to put our red lead on bus ground, that's the minus terminal, black lead on L1. 0.767 volt diode drop, L2, 0.467 volt diode drop, L3, 0.467 volt diode drop. We already did plus bus to bus ground. Let's go black lead with U, 0.360 volt diode drop. Here's V, 0.361 volt diode drop. Here's W with the black lead, red lead on bus ground, 0.360 volt diode drop. Let's go look at PB with the black lead, 0.366 volt diode drop. No short circuits and no opens. So we are going to apply 380 volts AC 3-phase to L1, L2, and L3, and we'll see if we can power up this drive, if it actually does have a problem powering up. All right, we have the 380 volts AC 3-phase connected to L1, L2, and L3. Let me double check. Yes, that's L1, L2, and L3. It's not powered up yet, but we'll get there. All right, all. Hold on to your farm animals. Here we go. Sounds like it powered up to me. Yep, we got EDOH, that's our motor thermal alarm. And that goes down to this OH terminals right here. Huh. Well, what do you know? This looks like this is going to be an easy one. They must have a problem with their line voltage coming into this drive. There might be a contactor that's not closing that connects the L1, 2, and L3 of the drive to the line voltage. Huh. Well, let's see if we can run it. I'm going to power it down, let that DC bus de-energize. After that bus de-energizes, we'll hook it up, see if we can run it. Alright, I'm going to power up the drive, and we're going to run it unloaded of UV and W. And we'll see what happens. Alright, here we go. That's very strange. I didn't hear the pre-charge contactor energize that time. So we do have a problem with this drive. We're going to have to go in and figure out why it didn't energize. We should have heard that ka-chunk like the first time we heard it when we powered up. Well, I have 2 hertz displayed on the HMI panel. Here we're going to enable. There's 64.9 hertz. Wow, that's 800 hertz max. That's moving. Okay. Well, you know what? Let me show you what I saw in a previous drive that wouldn't power up. This might help you in the future if you ever get one of these KEBs that won't power up. We're going to go over in front of this cooling fan right here. We're going to look down inside and we'll see a red LED. And then we'll look at my drawings of that circuit. And we can look down inside here and see that red LED turned on. And if that red LED is off, when you power up a drive, this type of drive, unless you see that red LED on, that drive's not going to power up. And I'll show you why. Here in just a sec. Let's get over to the bench and we'll talk about my drawing. I still have to go into this drive and find out why that pre-charge contactor didn't pull in. But the logic and the DC bus are coming up. Right here is the red LED behind that cooling fan. And you can see we have plus bus here, they call it plus UZK, a series 18 kilo ohm 20 watt resistor in series with another 18 kilo ohm 20 watt resistor. The LED forward biased into this hybrid module. This is for the switch mode power supply. So if for some reason you see that red LED turned off, that power supply is not going to come up. And what usually happens is that one of these resistors will open up. And I kept the resistors. Let's go measure them. These are from a previous repair. They stood up on the board. And the funny thing is that there's, let me get in the frame, there's one way over on one side of the drive, and there's one way over on the other side of the drive. I don't know why they did that. So let's bring our meter in and we'll look at these 2 resistors. Get this turned around and the light turned on. Let's get in the picture. I'm to go to ohms mode. Turn the light on. I'm not sure which is the bad one. I didn't mark them. We'll find out here in a second. Okay, that's the one that's opened up right there. We have open lead, OL, in the meter display. Let's pull the other one in. This one should be good, unless I've forgotten how to measure resistance. There we go, 19.79 kilo ohms. That is a good resistor, and this is the bad resistor. Amazing how that happens. Okay, so if in the future you look through that cooling fan and don't see that LED on, take a look at one of these two resistors. If they're good, check the LED. The LED could have opened up. Or check the DC bus. If you don't have a DC bus, that circuit won't power up. Okay, I still have to go into that drive and find out why that pre-charge contactor didn't energize. Let's get ourselves unplugged from the power plant. Controls. Have that undone. Let's lay those down over here. Just pull that display off. Undo my jumper from the OH terminals. OH terminals are for the motor thermal. I could have put this terminal in a better place. It's right behind this strut. Hard to get that in there and connect it. You just got to do what you got to do, I guess. Cover panel. Okay. There's a cover plate over the CPU board that we have to pull off. Clips in over here. Side. Got that side. It's kind of hard to get out. Pops up like that. You have to tug on it pretty hard. Now, I see a lot of sawdust. Maybe that is why the contactor's not pulling in. Hopefully all we got to do is blow that contactor out. We'll be all right. Okay, here's the CPU board. It's ribbon cable right here we have to undo to get it out. Alright, where's my hold up? There we go. There's our CPU board. Let's get some pictures so we can get this hooked up properly. Few connections here we have to undo before we can get that cover off. One of them's a cooling fan wire. It runs through the connector. Okay. Now there's a couple of clips on the back side. Couple of clips back here that we have to undo before that cover will come off. This is pretty stout plastic. Need more than one screwdriver. Side. Don't pop back in. There's the other side. Here's the cooling fan wire, and it runs through that little bracket right there. Oh, oh, you see all that sawdust? Ah, what a mess. Okay, we're going to blow the sawdust out of this drive. Hopefully, that's our problem. I can move it up and down, but maybe the sawdust is between the magnet and the coil. This is our pre-charge contactor right here. The first time we powered this up, we heard it energize. But then, on the last couple of power-ups, it would not energize. Let's go fire up the air compressor. We'll roll over to the air compressor and blow that sawdust down. sawdust blowing out of the contactor, the pre-charge contactor right here. Let me show you where those 18 kilo ohm resistors are if you ever have to replace them. There's one right here alongside the bus capacitors. And then if we go all the way over to the other side of the board, here's the other one. And let me show you where the LED is in the hybrid module. There's the LED. And here's the hybrid module. And on this heat sink assembly right here is the switching MOSFET that switches into this transformer being driven, the gate being driven by the hybrid module. Let's go back over here to the pre-charge contactor. This right here, the wires go to the solenoid of the pre-charge contactor. Our connection to the board is a little bit loose. I wonder if that could be our problem. I wonder if I could cinch up those socket pins. I don't know. We'll see. It's not much better. Let's go ahead and hook it up and see what we get. Go. We're going to plug back into the power plant. Turn the transformer on to apply 380 volts AC 3-phase to L1, L2, and L3. Let's see what happens this time. I still don't see that contactor coming in. Oh, jiggle the wire. Be careful. Oh. Huh. Okay. Looks like we're going to take that contactor out and test it. We power down. Here we are, day 2. Now, I was at the house last night thinking about this drive. I do my best thinking when I'm not at the shop. And I need to see if I actually have 24 volts to power up that solenoid. So we're going to put our meter right here and unhook that connector. Put our meter in volt mode. Get some clip leads and a little screwdriver to help us undo that connector from the power board. Some clip leads so we can clip onto the pins of that power board connector. Then we'll power up the drive. Okay, let's move that out of the way. I might have these hooked up backwards so we see a negative sign in the display, but that's okay as long as there's somewhere around 24 volts DC from that connector. Alright, here we go. Let's see what we have. Yes. I don't know if you can see it, but I have 25.78 volts DC on that connector. So that a pre-charge contactor should have energized. Just powered down the drive. We're going to pull that pre-charge contactor and determine what's wrong with it. It's probably still full of sawdust. That's my thinking. Okay. Just going to undo these screws real quick. Need to make sure that DC bus is not energized. Not touching the metal of the screwdriver. See, the red LED is still on just a little bit. So we want to wait a little bit before we get across those contacts there. Let's see what our bus measures like. There's 26, 25, 24 volts DC. We'll wait a little bit before we get around to pulling those wires off of that contactor. Okay, it's been a while. Let's see what our DC bus measures like now. 1.602 volts DC. I think we can work on that pre-charge contactor now. Okay, just undid this cable here. And I think we're going to have to disconnect that from the DIN rail if I can get it unlocked. Last time I tried to do this, I couldn't get it unlocked because the power board was in the way. I think we're gonna have to pull that power board off. Yeah. Okay, I have it unlocked from the DIN rail, but it's buttoned up against the power board over here on this side. We're gonna have to pull that power board. Okay. If it ain't one thing, it's another. Simple job of cleaning the contactor turns into a chore. Go ahead and undo our line wires. We're disconnected from the power plant, so we'll be okay. First, we will remove the CPU board. Now we have to undo the gate emitter wires. If I can get down in here without busting those hybrid modules. Let's see if I can get try this IC puller down here. One. Okay, there's that one. That one. Okay. We have all those done. Now we've got to come over to the other side. We have the pre-charge contactor main bus wires removed. We have the gate emitters, high side and low side. These three are high side, and this one is the three low side gate emitter firing channels. We got to come over to the other side and undo some connections over there. Okay. Now, to remove the screws that mount power board. Is that everybody? Something else holding us up. What could it be? Oh, there, I think we got it. Just gotta move all this wire out of the way. Now we can remove the power board. There we go. See if we can get that off now. A little locking tab down here that locks it onto the DIN rail. Ah, we're free. Okay. Let's move this out of the way. Here's my drawing of the wiring, so we can get that wired back up correctly. Here we have a red wire jumped between these two terminals, and then we have a red wire jumped from this terminal to the black wire down here on this terminal, and then the red wire, this is A1 red wire, A2 on the black wire. Let's see if we have any coil resistance on the A1 and A2 terminals. Yes, we do. We have 727 ohms, 0.727 k ohms. You know what, let's put 24 volts on that coil and see if we can get it to energize out of the circuit before we tear into it. So our power supply to 24 volts DC. A couple of leads to put down this sockets of this connector so we can clip our 24 volts DC onto the coil. Okay. Ground of the 24 volts DC to the black wire, plus 24 volts DC from the power supply to the red wire. Here we go. Look at that. And we have 24.7 volts on the display of the power supply and 30 milliamps of current draw. But it's not energizing. Let's see if we can get inside. We'll undo the wires first. They got that plugged. I wonder why they plugged that one. See if I can get that plug off. Okay, there's that. Still sawdust in there. Look at all that sawdust. Even though I tried to blow it out yesterday, I didn't get all of it because we couldn't get inside. Let's get some pictures so we can get this thing put back together correctly. pull these contacts off. So I can pull this apart. Okay, let me go fire up the air compressor. Our air compressor's broken. So we gotta do this the old-fashioned way. There we go. Contact looks a little bit bad. This one too. It's the auxiliary contacts. Find some sandpaper. Oh, something interesting. So if we go between the A1 and the A2 terminals, we have 730 ohms. But now there's a wire over here on this terminal. And if we go from A2 to this terminal over here, we have the same, 725 ohms. But if you go over here to A1, you have 5.5 ohms. That's what I think would be a normal coil of coil resistance. Interesting. That's why that one red wire was jumped from up here down to the bottom terminal. Huh. Okay. Well, let's see if we can get her back together. Spring, don't forget the spring. run the screws in just a little bit. There's been one goat rope after another. I worked on worse contactors though. Worked on some that were just impossible to get apart and impossible to put back together. At least this one here gave us a chance. Alright, let's get wired back up. Now it should work. There we go. Let's test our continuity. It's energized. Here's L1 to T1 with good continuity. L2 to T2, good continuity. L3 to T3, good continuity. Okay, I'm going to reinstall that into the drive. Reassemble the drive. We'll try to run a motor. Okay, y'all can take a break. You don't need to watch me put this thing back together. Man, that was frustrating. But you got it. You got it. All right, folks. Good job. We'll put it back together. See what happens. Feeling real good about it, though. We got to see this pre-charge contactor energized. and de-energize, whereas when it was in the drive, it wouldn't do that. All right, we're all back together. Let's fire it up. Oh, wait, no, let's not fire it up. Let's power it up. All right, hold on to your horses. There you go. Did you hear that contactor come in? Did you see it come in? Sweet. All right, now the scary part. Let's see what happens when we enable it. 102.8, 102.9 hertz in the display. So go up to 800 hertz. Look at that. I'm adjusting the speed with my speed potentiometer. Okay. Now we're going to get the oscilloscope over here, and we'll look at the UVW waveforms when we enable it. Whew. So far, so good. All right, good job, folks. That was a grizzly bear, wasn't it? You resurrected another one from the dead. All right. Okay, I'm enabling the drive to run. We have 100 hertz in the display of the panel. We have 100 hertz on the Fluke oscilloscope. This is U to V. Spread that time out a little bit. There's our pulse width modulation. Bring the time back in. Next we'll look at U to W. Stopping the drive. Enabling the drive to run. Okay, that looks good. Now let's look at V to W. Stopping the drive, moving lead from U to V. Now we're looking at V to W. Enabling the drive to run. Nice. They all look the same. Good high side, low side firing. Enabling the drive to run. Looks good. Lowering the frequency. Increasing the frequency. There's 230 hertz. Get my glasses on so I can see that display. Oh, 240 hertz. There's 303.5 hertz. That's as far as I'm going to run it. I don't want to burn up my light bulbs. Okay, let's go back down to 100 hertz. All right. I was changing the frequency out with the speed potentiometer. There's 101 hertz. Okay, disabling the drive. The light bulbs simulate our motor. Okay, removing the line voltage. Did you hear that? The pre-charged contactor de-energized. All right, folks. Good job. You fixed another one. Now we'll put the covers on it tomorrow. Today's Sunday. We'll put the covers on it tomorrow, Monday, and ship her on out of here. She can go back to the factory, do some more work. Let's get on out of here, folks. We got other things to do. Spend some time with your families. Enjoy the time with your families and your friends. If you got animals, enjoy the time with them too. I'm sure they appreciate it. We'll see you when the sun comes up. Evening, everyone. Good to see you again. Now we're going to start out on the power side this time. Up here on L1, L2, and L3, I applied 380 volts AC 3-phase to power up that drive. Now the data plate says that you can apply 440 volts AC to 500 volts AC, and most folks use 460 to 480, but I powered up this drive with 380 volts AC 3-phase. Down here, the plus plus and the minus minus terminals, that's your plus bus and your bus ground. PB is where you attach a regenerative braking resistor from PB to plus bus. On the OH terminals, this is where you attach your motor thermal, but I didn't have a motor that runs off this drive, so I jumped that out. If you don't jump that out, you get the EDOH alarm. And down here, UV and W, I used a light bulb bank instead of a spindle motor. Now let's go over here and look at the control wiring. Up here on 1, 2, and 3 is a relay output. 4, 5, 6, and 7 are digital inputs. And the odd thing about pin 7 here, input 4, I had to attach that to terminal 14 UEXT. That's a plus voltage for the control switches. I had to attach pin 7 to pin 14 in order for me to change the frequency with the potentiometer. I don't understand why. I'd have to go into the parameters and to figure out what input 4 was set to. But if I did not jump 7 to 14, I would vary this potentiometer and the frequency did not change until I jumped 7 to 14. Now on pin 10, are we still in the frame? Pin 10 and pin 11, that's your run forward and run reverse. As before, UEXT is your voltage to control those inputs. UEXT on pin 14. Pin 16, 17, and 18, that's where I applied the potentiometer. This is our speed reference. On pin 16, reference to pin 18, we have plus 10 volts DC. The wiper of the potentiometer goes to pin 17. When we vary that voltage right there on pin 17, the drive would run faster or slower. On pin 19, connected to pin 14, that's our control release. This would be like our master enable. That drive will not run unless you apply that positive voltage to pin 19. Let's go look at the rest of that terminal. Down here is reset input. This would reset a fault if we applied pin 14 to pin 20. And pin 21, 22, and 23, that's the last of our terminal. This is our fault relay output. Now let's go back up. I skipped over it, but let's go back up to 12 and 13. This is an output, and usually out 1 on terminal 12. Usually, let me draw that in there if I can. Usually this is, I'm going to draw a current limiting resistor, an LED, sorry if I messed this up, to 13. Usually this relay, this output is on if there's no faults. If you have a fault, this LED, this output would be off. Oh, I butchered that, didn't I? Sorry. I'm reaching over the camera to go put that in there. So, output number 1 on terminal 12 is usually set up as, hey, we're good to go. We have no faults, or we have a fault. And if this would just simulate the output being on. If there's no faults, that LED would be on. And you can use maybe a 220 ohm resistor, I'm guessing. To be safe, you might want to put a 470 ohm resistor out there. I can't remember what the voltage is right here at the output when it's turned on. There we go. I hope that helps y'all go and test your KEB F4 drive of this configuration.